Hi, the section 7.2, linear discriminant analysis, an example. So the same example as the multinomial logit model. So the response variable is party. So we have three categories, either Democratic or Independent or Republican. And we only have the two predictors here, age and income. And we have three categories. So at least we need the two predictors. So we have the age and income here. And yep, and some prior probabilities. So this is the proportion of Democrat and Independent and Republican in the original data set. Okay, so this is the result of the fitting this LDA function. So it's the same as the regression form. So just the response tilde, then predictor plus predictor. And the group mean is important because we are thinking about the between group variability and the within group variability. So Democrat, on average, the age is 47.1 and the income is 37.6. And the Independent, slightly more income and age is almost the same. And the Republican, almost the same age, slightly higher and income higher than Democrat. Yeah, and then this is the result of the LDA. So this is the step one of the LDA. So basically, this is the coefficient. So age times 0.0053 plus income times 0.0332. So this is best linear combination to separate these three groups. And LD2 is the next one. So probably it's a little hard to interpret, but the LD1, both coefficients are positive. And it's a kind of understandable because the Democrat and the Republican are the largest groups. And the age and income are both higher for Republican. So that means maybe the age and income have a kind of similar impacts overall if we expect they exclude the Independent. So maybe their first component is both the positive coefficients. So that makes sense. But some irregularity, for example, the Independent is younger but the more income. So the second component is actually the positive negative. And the proportion of trace, so this basically explains the first, how much information first variable has, first component, first the transformed component has, and how much information second component has. So in this case, the first component has most information. So that is natural, except for very complicated classification problem. So this is the first component, and this is the second component. So it's not much information here because anyway, we only have two variables originally. If we have originally 100 variables, then doing the first step of LDA have a lot of information. Yeah, then we can get probabilities, the fitted probabilities by LDA. So after first step, we have to do the second step, then we fit the, second step, we fit the multivariate, the normal density, then we compare the probability. So we have many steps, but if you use the predict function, then we can immediately get these fitted probabilities. So you can see that these probabilities are similar to the rule by the multinomial logit model. So basically the multinomial, the logit model is also a linear model. So also we are kind of making the linear discrimination. So basically these two models are very similar and we get the very similar results. And the contingency table, then we can get the predicted class. So predict LDA of class. So previously probability, we get the predict function, then after that the posterior. The first object is posterior. And here that we use the class object. And this is the summarized table. And you can see that this one and this one and this one are correct categorization, and the others are not correct. And the proportion of correct categorization is 0.465. So it's slightly lower than the previous one, I mean, the multinomial logit. But overall, very similar. And you may wonder that why the no observations are categorized as the independent. And the typical case for linear discriminant analysis for 3 groups is, okay, so group one around here, and the group 2 around here, and group 3 around here. And then the discriminant, the separation is like this. So, but here, probably, so at first, probably it's happening is that the independent is just between Democrat and Republican. So if we think about the contour plot, so contour plot is like this, and the contour plot has the same shape. So like this, but for this one, for this specific data set, probably the independent is in between Democrat and Republican. So that means, okay, so we have the Republican group like this, and the Democrat, the estimated is this one, and the independent probably like this. So just in the middle, and maybe slightly off, but almost in the middle. And actually, after estimating these density function, so this LDA also considers how much observations are in the group originally. So originally, we have the 380 observations for Democrat, and the 325 for Republican, and the 239 for independent. So this probability, so overall 944. So the probability of the ratio, the sample proportion of these observations is multiplied by these observations. So I would say sample proportion as pi1 hat, and the pi2 hat, and pi3 hat. So to estimate the probability of each observation is in a Democrat, Republican, or independent, we have to multiply this the probability pi. And since this pi3 for independent is small, probably for any data point, even the data point around here, still the probability is either larger for Democrat or larger for Republican. So that's why the no observations are classified as independent. Yeah. So this is an example and interpretation of the linear discriminant analysis. These materials that will be covered in other courses, such as the Statistics 5820, that is the data science course offered next semester, and also the Stat the 7810. So that is the more higher level class, but these courses covers linear discriminant analysis in more details.